Hi class, today we're going to talk about preferences, which is between pages 14 and 24 in your textbook. When we talk about preferences, we're really talking very theoretical. There's no such thing as preferences being 2 times more or 4 times more. They're just a theoretical construct to help us define maximizing utility. And we say utility is a function of two goods, food and other goods, or whatever goods you have. That's equation 2.5 in your text. Now there are some things that we say are related to preferences, and these are assumptions of preferences. And the first says that you can rank your preferences. I can tell you that good 1 is better than good 2. I can say A is greater than B, or B is greater than A. Also, I can say that my ability to rate preferences is complete. So for completeness, I can tell you that A is preferred to B, B is preferred to A, or I prefer them equally. They are complete. There's a third axiom of preference called transitivity, and I can say that if I prefer A to B and I prefer B to C, then I must prefer A to C. Also, I have an axiom continuity, meaning that I have closed sets. I can't say I prefer A to B along some continuum and then I prefer B to C along another continuum. And then I also have non-satiation, or more is better. Right there, many of you are going to jump up and down and you'll say a better environment is preferred to a worse environment, which means more garbage is not preferred to less garbage. In that case, all I have to do is multiply everything by a negative and my models will still work. So don't let that keep you from using these models in order to understand consumer choice. Okay, so let's look at some indifference curves. You say, oh, indifference curves. What's an indifference curve? An indifference curve is a negatively sloped curve that represents consumer preferences. And there are an infinite number of these. But I do know that I prefer to be on a higher one than a lower one. So what are some characteristics of these? Well, notice that they're negatively sloped. And what does that mean? To find the slope of a curve, I draw a line tangent to a point along that curve. And you can notice that the slopes of these tangent lines are declining marginal utility. In regular words, what does that mean? It means the more I have of a certain good, here I have a lot of food and a relatively small amount of other goods, the more I'm willing to give up of it to get 1 unit more of another good. I'm willing to give up a lot of food when I have a lot of it and a little bit of the other good to get 1 more unit of the other good. So I have declining marginal substitution. I also am going to say that I can never have an indifference curve that crosses. Why? Because in this case, along the curve AC, it says I'm equally happy than I am along the curve BC. But BC contains more of good B, and therefore that cannot happen. So indifference curves cannot cross. The other thing, just so you know, that cannot happen with indifference curves is they can't be positively sloped, because if they were positively sloped, point B has more of both food and other goods than point A, and that would tell me that if more is better, then I cannot be equally as happy at point B as I am from point A. Another thing that the shape of indifference curves help me to identify is whether or not I have goods that are substitutes or goods that are complements. An indifference curve that is shaped like this, where there's a one-to-one relationship these are perfect substitutes. Some people might say coffee and tea, perhaps. Or I can have an indifference curve that looks like this, which says things are perfect complements. You have to give me more of good, the good on the horizontal axis, if you're going to give me more of good on the vertical axis. And this might be pancakes and syrup. For our purposes, we're going to say that we assume our indifference curves look like these. Negatively sloped, infinite number moving out from the origin. More is better. I can choose declining marginal substitution. Those are some concepts of indifference curves.